In this video, we're going to implement recursive forecasting. So we're going to use a LASSO regression model multiple times to predict various steps of energy demand in the future. And we're going to use a Python library that is called Skforecast. And if you are not familiar with this library, I suggest you take a look at it because it's really useful for forecasting with traditional machine learning models, but it also has forecasting with deep learning, probabilistic forecasting, and much more. So in order to make recursive forecasting, we need to import the ForecasterAutoRegressor. And we're going to use LASSO, and we're going to evaluate model performance with the root of the mean square error. In order to focus in how to implement recursive forecasting, we're going to keep everything else as we have done in the previous section. So we're going to use the energy demand in Australia. So in this time series, we have energy demand at each hour from 2002 to February 2015. So here we have some of the time series values. We're going to separate the dataset into a train and a test set. Again, we take all data up to the end of 2014 in the train set, and we leave the first 2 months of 2015 in the test set. Here we plot the time series, so this is how it looks like. All the blue data is the train test, and in orange the test set. We cannot really see much, so here we zoom in. We take just 2000 points, the last 2000 points from the train set, and we plot the test set. Again, we don't see much, so we zoom in a little bit more. Here we have the last 500 points from the train set and the first 500 points from the test set. So this is how our time series looks like. So how do we set up a forecaster to do recursive forecasting? The first thing that we need to do is to set up the regression model that we want to use. Here I'm going to use LASSO, but you can use any other model from the scikit-learn library that makes regression. So we pass the LASSO model that we just created to the regressor parameter. This is the machine learning model. And spoiler alert, you can also pass pipelines. Then Skforecast will create automatically lag features as of the current implementation, and you can create as many lag features as you want. You can pass a list of lags. So if we pass a list, it will create the lag of 1, lag of 24, and lag of 6 days, like we did in the previous section. If you just passed 24, for example, as an integer, it will create the lag of 1, 2, 3, 4, 5, all the way to 24. So more details about this can be found in the ForecasterAutoRegressor documentation. Here you can give the forecaster a name. And once we have this, we fit the forecaster to the time series in the train set. So what this forecaster is going to do is going to take this time series, create the lag of 1, the lag of 24, and the lag of 6 days, then split the data into these 3 features and keep the demand as a target and fit a LASSO. This is what we did manually in section 1. So all of this is done under the hood by the ForecasterAutoRegressor when we fit the forecaster to the time series. So I repeat, it takes the time series, it creates the lag of 1, 24, and 6, then splits the data, it keeps the predictors on one side and the time series on the other side, and to that it fits a LASSO regression. If you print the forecaster, you will have some data that is actually useful when you want to predict future data. Here it tells you which model you trained, which lags you created, and here it tells you basically how many time points in the past have been used to create the features. And here it says the window size. The window size is the size of historical data that you need to predict the first step in the horizon. So in order to predict the first step, you will need to feed this forecaster at least 144 points of historical data, and this usually coincides with the bigger lag. We're going to talk about these parameters in coming videos. This is to help you transform the time series. For example, if you want to smooth it, or here if you want to add exogenous data or more feature transformations. This is if you want to weight the feature creation. You can also differentiate the time series, etc. There is a lot of things that you can do out of the box with this forecaster. The important thing is the range of the train set, because this means that this forecaster will be able to predict out of the box the next steps into the future, starting one step after the last of December of 2014. And we will see how to do that right now. If I take this forecaster that already contains a LASSO model trained on the data, and I ask it to predict the next 24 steps, what this forecaster is going to do is what we described in the previous video. It will take the LASSO to predict the first time point in the future, which is this one. Then it will use this value to recreate all the lags, and then it will use the LASSO again to predict this value. Then it will use this value to recreate all the lags, and use the LASSO again to predict the next value, use this value to recreate all the lags, and so on 24 times. So because this does everything out of the hood, we really don't know what's going on behind the curtain unless we go to the source code, but believe me if you want, or you can also check the source code, this is what's happening when we use this forecaster from Skforecast. So now we can go ahead and plot the predicted values. So here I take the last 100 points of the training set, and I plot the first 24 points of the test set, and I overlay the predictions, which is just 24 points. And here we can see that this LASSO regression with the recursive strategy is making decent forecasts. We can go ahead and determine the mean squared errors. We use the mean square error function from scikit-learn. We pass the first 24 points of the dataset that contain the real values and the predictions. And here we obtain the mean squared error. So as I said, this forecaster can produce out of the box the next 24 points right after the last point of the training set, because I have all the historical data prior to this first point. But if I wanted to predict some point here, I need 144 time points in the past, which are not in the trained forecaster. So in order to predict some point here, I need to pass to the forecaster the historical data that I have right before that point. So let's do just that. So in order to predict any point in the future, and here I'm trying to simulate how I would use this model in production. So I have this model in production, and my stakeholder comes and says, hey, can you please predict energy consumption starting the 1st of February? And then I would say, yes. In my scenario, if I want to predict energy from the 1st of February at midnight, I have all the data right before that. So what I need to do is I need to create the window of past available data that is the time point right before the point that I want to predict. So this is 1 hour before, and actually 144 time points back, because remember that I need at least 144 energy consumption points in the past to be able to create the lag 6 days. So this that I'm doing here is quite horrendous actually, because I'm taking the last points of the test set and then basically counting backwards 144. Don't do it like this. It's better to write here the starting point of your historical data and the end point of your historical data. But if you forgive me for this demo, here we have the history of data that we're going to pass to this forecaster. Remember that this is data that we know if we want to forecast this time point. So what we do here is we take the forecaster that contains the trained LASSO, we apply predict, we tell the model how many steps in the future I want to predict, 24, and here we need to pass the historical data respect to the time point that I want to predict. and the historical data is up to January 31st, 23 hours, so this forecaster autoregressor automatically knows that the first point of the prediction is going to be the 1st of February at midnight, which is what we wanted to predict here. So have a go, practice by using several times of windows into the future that you want to predict to get familiar with how this forecaster works, but you get addicted to it. Once you use it, you basically cannot go back to pandas anymore. So I'm going to basically plot the new predictions against the reals. So here we have the data in the test set from this time point and then 24 points into the future. Like I know that data because I'm basically evaluating the forecast here. It's not that I'm making real predictions. And then I pass the predictions and we can see that it's fairly decent as well. So we can go again and determine the medium square error, and we see this value here. Now we've done 2 forecasting windows here. We predicted from February onwards, and some time back we predicted from January onwards. How many forecasts do I need to evaluate to make sure that my model works? Yeah, that's a good question, and that is coming in section 6. So stay tuned for more info. In this section, we're going to focus on how to forecast multiple steps with direct and recursive forecasting. Now, the forecasting autoregressor produces out-of-the-box lag features, but we talked about window features, daytime features, etc. How can we do that using Skforecast? That is coming in the next video.